Today is this one here. I think I've done the first two already. So can you? I've done the first two in the class. So, So can you? Number 3 is a little bit difficult. I've done 1. I've done 2. Number 3 is a little bit difficult. So can you try number 4, please? Question 4. Yeah, this is all on stuff that we talked about on Wednesday this week. Come on. So can you guys work on question 4? I'll show you. If you have problems, I will show you. I'll give you a few minutes and see. Right, guys. Hey, Robert. Sorry, yeah. You got a question?
I've noticed in the sheet that if the Earth was finite, then it doesn't hold, whereas if it was infinity, then it does hold. Is that like a general? Is that true? Like a general remark?
Which question are you referring to?
Well, no, just the whole sheet. I found that if the WF wasn't infinity, then the ETT doesn't hold. So is that like a general rule?
No. The rule is that if the limit is 0, right, then it does hold. Whereas if the limit is not 0, then it doesn't hold. That's the rule.
Because if WF is finite, then doesn't like that fraction reduce to probably that x is equal to WF divided by probably that x is equal to WF. Just in the way like the denominator you do 1 minus everything below. Like, see what I'm trying to say?
Yeah, I kind of see. Yeah, I mean, if you have a finite operating point, you can have. Yeah, it's unlikely to hold. But it's. We can't hear you. What's the problem? Can you hear me, guys, or not? Hello, guys. No. Why is that? Why can't you hear me? Maybe some room, you see. Can you hear me now or not? You can't hear me? I don't know what the issue is, but can any of you hear me, guys, on the Zoom? All right. Anyway, let's. All right. I see what your question is, Robert. Yeah. If it is a finite endpoint, then it's unlikely to hold. But there are also cases where your endpoint is infinity and still not hold. So it's not a rule. Some people say I can hear you. All right. It's not a rule as such. Okay. It seems audio, everything is working. I don't know. Please let me know. Those of you who are on Zoom, if you can't hear me, let me know, okay? All right. Anyway, are you guys doing question 4 or what? I asked you to do question 4. So, I don't know what the issue is. If you can hear me or if you cannot hear me, please let me know, guys. Huh? Are you alright, guys? By the way, did you all get the quiz 1 back? I sent it to you last, was it yesterday or day before? On Wednesday, yeah. Did you, please. All right. Are you guys doing question 4 or what? Have you attempted question? Are you okay, Nicholas?
Yes.
Veronica, all of you guys okay?
So we do not need to do question 3, right?
Yeah, question 3 is a bit difficult. Let me see. Hello? Not this one, the other way. Shit. Come on, man. I don't know how to use all this. All right, sorry. I mean, I don't know how to use the equipment here, but all right. How far have you got with question 4, guys? We did the first 2 questions during the review session on Wednesday, right? So if you were in the review session or if you're not, you should know how to do this too, right? And question 3 is a little difficult, so I skipped it. So let's go to question 4. Yeah, I completed it. Yeah, uploaded it, yeah. Then you say it's on the course website. It's on the course website. I uploaded the completed version of the Poisson. Remember, during the review session, I did 3 examples. The first two in this sheet, plus the Poisson example, which I could not finish, but I did finish it after returning to my room, and I uploaded it. If you haven't seen it, please go to the course website, and you'll be able to see that. All right. Anyway, let's look at. I'm sorry if you can't hear me. I don't know. I'm not a computer person here. Don't know anything. Right. So this is the probability mass function. Yeah. So so the W of F will be what? Yes. What? It will be plus infinity. Yeah. So we need to find the limit okay, guys. So this is the limit as k goes to infinity of the probability that x equal to k right. Okay. By the way, do you have any questions on the quiz 1? Did you look at the solutions of quiz 1 if you didn't get it correct? I know quite a few did not have problems. Are you okay with the did you guys look at the solutions for quiz 1? Yeah? Alright guys, are you okay with me so far? So now what I'm going to do is I'm going to put this is the probability mass function at k. And what you have in the bottom is yeah. Are you with me guys so far? Right, now you see that this function here is a constant, so it cancels out, right? Right. Now the question is how to find the limit of this. So to find the limit of this, you need to apply some trick from your analysis. I know all of you guys did analysis in your first or second year undergraduate study. You may recall that, or you should don't know, just try to figure this out. There is a result which says the following. Right, that if you have a sum, say from j equal to k to infinity of g of j, where g is a function, right, then it behaves approximately as the integral of g x dx as k goes to infinity. This is this is true for certain functions. Certain functions g. Okay? That is, what I've done here is to replace the sum by an integral, because as you know, like in mathematics, integration is easier to do than summation often. Right? So instead of dealing with the summation, we are replacing it by an integral, right, which may be easier to work out. Okay? All right. Now, using this result, which you may not or may know, remember, right? We can write the above as the limit from k to infinity of, right, and the denominator, which is this, can be replaced by the integral from k to infinity of, right, and this integral is easier to work out than the summation, which is this, right? I'm sure all of you know how to do this integration. If you do this integration, you will get this is what you get, right? It's a simple integration, right? All of you okay? Yeah or no? You lost time. And then this becomes the limit now at infinity. I'm going to suppose it's 0. I will explain why. I will explain why it is the case. It's 0 if 1 minus s is less than. Okay, I'm going to assume this. Otherwise, you can't do this question. If you assume that 1 minus s is a negative number, then at infinity, if you put x equal to infinity here, you will get this to be 0. Yeah? So you need to assume this. Okay, so this is what you get. Now this is equal to the limit as k goes to infinity of s minus 1 divided by k. Right? Now as k goes to infinity, this goes to 0. So the limit is equal to 0, which means that the extremal types theorem will hold. So this implies that the ETT will hold. But then in order to work out the limit, which of the three, you need to go back and check the conditions. Condition 1, 2 or 3. And to see if which one of them is actually holds. But that's not the purpose here, all right? Just so that's the end of question 4. Is this okay, guys, all of you? Hello, guys, on the Zoom. Any questions, guys? I don't know why these guys can't hear me. Oh. All right, can you do the next question, please? Question 5 on the tutorial sheet. So this we are done. We are done number 4, and the next one is number 5. All right, how far have you got, guys, with question 5?
Yeah.
I mean, you don't need to use my solutions. I mean, you can do it in different ways, right? So you don't need to follow my solutions. You know what I'm saying? So you can do it in whatever way you like. So this is question 5. So you have, this is the the PMF, and this is the CDF. And clearly, since k is greater than or equal to 1, W of f is plus infinity. Right? So what you need to work out is the limit okay. All right, let's put things here. So this is gonna be the limit as k goes to infinity of this is the probability mass function, which is log base 2 of and then in the denominator you have okay. So this is, you guys okay? Right, now I'm gonna simplify things a bit. Right. The 1 and the 1 cancels out. Okay, so you get now you can take the common factor k plus 1 squared, right? So it becomes k plus 1 squared minus 1, and in the bottom these two cancel out and the minus minus gives you plus. So this is log of base 2 of alright guys, so this becomes the limit now. This is log base 2 of k plus 1 squared, take away 1 is k is k squared plus 2k, right? So it's going to be k squared plus 2k divided by okay. All right, now you know the rule for logs, that the log of a quotient is the difference of the logs, right? I'm sure you know that, right? So using that fact, you can express this as minus log of 2 right, that's in the numerator, and in the denominator you have log okay. Excuse me. All right, in the next step I'm gonna use the L'Hopital's rule, because as k goes to infinity you have the top going to infinity and the bottom also going to infinity, right? So the idea is it's best place to use the L'Hopital's rule. Now, this is where you will find the following useful. When you differentiate log base 2 of x is the same as log base e of 2 times 1 over x. So this is, I thought if you don't know this, try to, I will not ask you this in the exam, but this is a useful result to know that the derivative of log base 2 is equal to this, right? Okay. So using this fact, you can differentiate the top and the bottom. So you get the limit of and in the bottom you get alright, so I've used the L'Hopital's rule here, right? And you will see these two, all of these guys cancel, right? Are you guys with me? Yeah. So let me take this away. So hopefully you are following me. Now, so a lot of things will simplify. So in the top, you have 2 times k plus 1 divided by k times k plus 2, because there's a minus here, I think. Then plus 2 divided by k plus 1. And in the bottom you have 1 over k plus 1 divided by 1 over k. Okay? Are you with me? Correct me if I'm wrong. Quite possible. So, now this guy here is equal to minus 1 over k times k plus 1, or k plus 1 times k. Right? Okay? So this will become the limit of minus minus will give you plus, so it is 2 times k plus 1 squared divided by k plus 2, and over here you get minus 2 times k. Okay, this is what you will get. Okay, now you should take the common factor. There is a 2 which is common between the two, so you can pull it outside. Then you have k plus 1 squared minus k times k plus 2 divided by k plus 2, right? And so this will become 2 times the limit as k goes to infinity of 1 divided by k plus 2, and this is equal to 0. So the answer is, once again, that the limit is 0, and hence the ATT must hold. So hence I hope you followed my working out. Are you guys okay or no? You're all right, man? If you're not okay, just let me know. Alright, the question number 6 is difficult. Can you go to question 7, please, which is the last question? Can you do question 7 on the tutorial sheet? Question number 7. So in this question, guys, you are given the CDF. So your f of x is 1 minus q x plus 1 to the power a, right? Where x goes from 0, 1, 2, etc. So clearly the upper end point is infinity. Yeah. So what you need to work out is the limit as k goes to infinity of this. Yeah. Now, what you are given is, you're not given the probability mass function. Now, you know for a discrete random variable, do you know this result? I mean, you should let me know if you don't know this. The probability that x equal to k is the same as the... Do you know this result? Yeah? You've seen this before, right? So this is the result I'm going to use. So this guy here, you can write it as limit k goes to infinity of f of k is 1 minus and f at k minus 1 is this, then you have okay guys, so the 1 and the 1 cancels, so what you have is the limit as k goes to infinity of q okay, so this becomes the limit as k goes to infinity of you with me so far, guys? Alright, now the next thing I'm going to do is the limit as k goes to infinity of, I'm going to pull out the k from this term here. So if I do that, you get k times 1 divided by k plus 1. You see what I've done? I have written k plus 1 as k times 1 plus 1 over k, right? Now, so you have k. So I'm gonna do this. This is a common term between these two, right? So you have in brackets okay, in the next page I'm going to use something called the binomial X series. I don't know whether I'm sure you know this. Do you know something called the binomial expansion or series, which says the following? I'm running out of time, let me know. which says the following, that you should have something like 1 plus x power a, right? This is the same as I'm sure have you seen this before? You've probably seen this somewhere in your courses. This is known as the binomial expansion, right? So I'm going to apply this to this term here. Okay? So what you get is excuse me. Yeah, this is what you get. And now let's look at the first few terms of this expansion. The first term in the expansion is when j is equal to 0. Right? When j is equal to 0, what you have is 1. Right? And when j is equal to 1, what you have is 1 over k. Sorry, not 1 over k, a over k. A divided by k. And when j is equal to 2, you have 8 times a minus 1 divided by 2k squared. You see, these are the first three terms. The first 3 terms of this expansion are this, and this. You follow me? Okay? And so on. And then you take away 1. Then you take away 1 here too. Alright? So this one goes with this one. Alright? So what you have is the limit as k goes to infinity of q to the power alright, multiplying this with this, you get 8 times k power a minus 1. Multiplying this with this, you get 8 times a minus 1 divided by 2 times k plus a minus k power this, and so on. Right? Minus 1. I hope I'm doing this correct. Let me know if I made any mistakes. Right? Okay? So this is what you get. Now, what matters is, as k goes to infinity, what matters is the leading term. So you can forget about this term. This is the leading term. Right? This is the leading term, right? So what you're looking at is basically the behavior or the limit of what you're looking at is the limit of this as k goes to infinity. Now basically, to consider this, you need to consider 3 cases. Because of this a minus 1 thing here, you need to consider 3 cases. The first is the case where a is greater than 1. Now if a is greater than 1, what will happen to this as k goes to infinity? It will go to infinity, right? So you have q to the power infinity, which is, q is a number between 0 and 1. Yeah. Q q, I mean, if you look at the question, it says q is a number between 0 and 1. So q to the power infinity will be 0. Q to the power infinity will be 0, right? Okay, so this will be equal to 0 minus 1, which is minus 1. Okay, and if a is equal to less than 1, if a is less than 1, right, then a minus 1 will be negative, so k to the power infinity's power negative is 0, so this would be 1 minus 1, which is 0. And finally, if a is equal to 1, this will be k to the power 0, which is 1. So this will be q to the power a, so which is q, right, minus 1. So these are the three possible limits. Sorry, these are the three possible limits that you will get depending on the values for a. So the only possible case, the only case that where the extreme multiples theorem will hold is when a is less than 1. In the other cases, the extreme multiples theorem will not hold. Right? Are you guys okay with this or not? Hello guys, are you okay or not? If I made any mistakes, please let me know. I might have thing in the calculations here. I think I left out a negative sign here. There is a negative sign missing here. So there is a negative sign I left out. So there should be a minus here, minus here, minus here, minus here, and so this will be plus 1. This will be or minus q. All right. Sorry about that, but I think the conclusion is the same. That is, the extreme multiples theorem holds if a is less than 1, and in other cases it will not hold. That is, if a is equal to 1 or greater than 1, it will not hold. Right? Are you guys okay? Any questions, guys? So you should have questions. So quiz 2, which is on this kind of stuff, right? Quiz 2 is due next Wednesday. So please try to submit your quiz 2 before Wednesday, or before 11 a.m. Wednesday. And if you have questions, of course, feel free to contact me. All right? Anytime. All right? Take care and have a good weekend. Okay. So yeah, just make this correction that I left out a negative sign. So the correct limits should be this. These are the correct limits. Those of you who are on Zoom, I'm sorry you couldn't hear me. I will try to fix this next week. Okay? Yeah, yeah.
So this will handle this one, it would be just the first thing, right?
Yeah.
So we would let the K plus 1.
Yeah, that's right. Yeah.
It would be 0, right? You will be left I do not understand this part. I have 1 over